Hey folks, John from Trucker Weather, Truckers Weather, Trucking Weather, everybody's weather, who cares weather, whether or not, whatever you need to call it, doesn't matter to me. Uh, we had a little couple videos back. Brian posted something about thunderstorms. It was actually a nice video. He had a lot of cloud lightning. It looked like he was a few miles away from most of the storms because you couldn't hear anything, didn't hear any much thunder, maybe some distant rumbling, but there was a lot of lightning. There may have been a little bit of clouds between him and the thunderstorm. It's my dog Casey in the background. So what we're looking at here is this UTP log diagram, or log P diagram, sorry. We will not be going into this. What I do want to point out here is this is weather balloon data. The, the line on the right is the temperature of the atmosphere through 200 millibars or 50,000 feet or so. And this is the dew point temperature. So what I want you to get out of this is there's nothing linear about this, right? It's jagged, it goes up, it goes down, and this is actually a relatively calm, nice sounding. It's not too wacky. Sometimes you can get warmer air, colder air, things that don't make a whole lot of sense. So that has a lot to do with instability of the atmosphere. So what I want you to think about when we're thinking about instability is I want you to think about a bubble of air. So picture that in your mind's eye, and in your mind's eye, have it rise up into the sky. Now, on its own, it will rise or continue to rise as long as it is warmer than the air that surrounds it. So if the bubble of air is 80 and the surrounding air is 77, it will continue to rise. And as it continues to rise, if it goes down to 74 and the surrounding air is 72, it'll continue to rise. That's an unstable atmosphere. You can get instability in different layers of the atmosphere. Sometimes the instability is right at the surface, sometimes the instability is in the middle, sometimes the instability is at the upper levels. You'll hear people talk about upper level lows. That generally means that there's an upper level instability, along with some other things that go on in weather, that allow clouds to form and probably precipitation. So, for a naturally, in the summer, a naturally unstable atmosphere will be an atmosphere that is generally unstable through most of its depth. The worst kind of atmosphere, and anybody that's from Texas or the Midwest or any of the tornado and nasty thunderstorm areas will know about, will be the worst part, or the worst kind of atmosphere will be a capped atmosphere. You'll hear capping inversion used a lot in weather forecasts in the Midwest and the tornado areas, because what that does is sort of keeps a lid on the boiling convection that's happening. But once it breaks through, it's able to explode into the atmosphere and it makes some really nasty storms. So you can get that, or you can get an unstable atmosphere that goes right through the whole thing. In that you'll get just some general thunderstorms from that. Usually they rain themselves out, but the capping inversions are the really nasty ones. So there's a certain kind of sounding that you see. It's called a loaded gun sounding. So it'll have a little bit of unstable atmosphere at the lower levels. It'll be really warm that day. High dew points, maybe in the 70s. It'll be 90, 80 degrees, 90 degrees. There'll be a little capping inversion at about 850 millibars or so, but it'll be thin enough that once enough heat and buoyancy happens in the atmosphere, those little bubbles of air that we were talking about, once they get going, they're able to break through that thin layer of capping inversion, and that's when you really get explosions of thunderstorms, because it's above that, it's unstable. So again, if it's unstable, the air is always warmer than the surrounding areas. So if you can, especially if you get a area where it's colder, Like if it blows through the capping inversion in the area of 500, 400 millibars, which again, we're talking about heights. This is this and this excuse me, on this map, 500 millibars is 5,720 meters. You can do the math on that. So these, these don't be confused. These are just pressure lines, but they have an equivalent in um, actual height, which changes, by the way, but that's another thing. So that's the general idea of instability. So what you need for any sort of storm, either a general rainstorm or a thunderstorm or a snowstorm, is you need some sort of warmer than the surrounding air, moist air to get into the upper levels of the atmosphere. In the winter, you can get that by having a warm front or a little bit warmer and moister air go over the dome of a cold, high pressure system. So it rides over the top of that. Cold air is denser than warm air, believe it or not. It's kind of counterintuitive because you think that moist, soupy air would be denser. It's not. Just got to trust us on this. Pilots know this. It's easier to take a plane, have a plane take off in the winter than it is in the summer. They need less runway. So you can get that in the winter where warmer and moister air rides over the top of colder air. You can get different types of lift. Fronts will do this, cold fronts, warm fronts, things like that. Any clash of air that has the ability to throw up moist and warmer air into the atmosphere. Now we're talking not talking about huge differences. It doesn't have to be. Like in the winter, we could be talking about a dome of high pressure that it's 20 degrees, and in the middle atmosphere there could be something coming through at about 30. That's enough. And then the other thing that you'll hear a lot of in the Midwest is the dry line. That's another way that stuff can get shot into the atmosphere. Dry lines will cause severe weather too. Dry air is denser than moist air, along with cold. That's one of the reasons why cold air is, because it's usually less moist. So all of this data, all this stuff that we look at all the time, the 200 millibar, 500, here's 200 here. Here's, let's change this sector view so we're looking at the country, not just my area. So here's the United States again. All of this data comes from weather balloons. They're launched from, I think, every weather service site does them. I think there's other ways that they get this information. I think airplanes, boats, some other things, but the weather balloons are one of the main ones. So they take readings of the atmosphere from the surface up to sometimes 90,000 feet, and then the weather balloon will burst. So they take dew point, they take temperature, they take pressure readings, they take wind speed. All of that data gets ingested by supercomputers, and that's what makes these models that we've been looking at. This is what allows me to use this little slider, because all that data is ingested into equations in supercomputers, and it figures out what's going to happen next. You would really need to have the entirety of the atmosphere covered to have it perfect. And we're talking about almost every molecule of air. That will never happen. So there's gaps in the data, and because there's gaps in the data, if you remember from your math days, the more errors you have in there, the bigger the error can be. So the errors will sort of compound on each other. So after a while, this particular GFS, the Global Forecast System, just gets wildly crazy if you go out too far. This is Monday here, and I can go all the way out to 384 hours or July 29th, and that's going to be the least accurate because it's just way too far. There's just too many errors in there. So without getting too much farther into that, that's the general idea of instability. So what Brian, that day that Brian was watching those thunderstorms, that warm moist air had gotten high enough and was shooting into the atmosphere at a rate that was high enough to make clouds that were tall enough to make lightning, because There has to be a separation in charge. If you want to know what buoyancy is like at certain areas when it's really nasty, in other words, when it's really convective, take a ball, playground ball, go in the pool, and push it down to the bottom and let it go. That's the kind of buoyancy we're talking about in severe thunderstorms. In a severe thunderstorm, you can have an unstable atmosphere that creates lift or buoyancy in these convective clouds of 100 miles an hour. I mean, this wind is flying, and these are the things that cause tornadoes because you're really creating a vacuum, so it has to fill in, and if you get the right conditions, that starts to turn on itself. So that's how tornadoes happen. That's it for trucker weather. Any questions, comments? Feel free to ask. I have my own channel too, John Carnevale, and or you can comment on the post on Brian's page. Sorry, end of the day. I'm tired. See ya.